let me briefly introduce the third speaker, Ryan Lee, who's actually a colleague of mine at Princeton. We're both grad students at Princeton, but he's senior than me. And then now he's a scientific data engineer at Lawrence Berkeley National Laboratory, and he's going to talk about extending the Neurodata Without Borders data standard to handle new data types and use cases. Okay, let's welcome Ryan.
Thanks, Anqi. All right, so I'll share my screen. Present tomorrow. Okay, can you see my screen? Okay, great. Hi, everyone. I'm Ryan. As Anqi mentioned, I'm a scientific data engineer at Lawrence Berkeley National Labs and core developer of the Neurodata Without Borders data standard. In this brief talk, I will quickly explain what NWB, or Neurodata Without Borders, is and why the field of cellular neurophysiology needs a data standard such as NWB. Then I will introduce the concept of extensions to NWB and how to work with them. So briefly, neuroscience has some major data problems. First, as you may know, almost every neuroscience lab has a different way of storing their data. Sometimes every member of a lab has a unique way of storing their data. This heterogeneity makes sharing data within a lab and with collaborators and with the broader community difficult and tedious, and kind of disincentivizes us to do so. Second, data often has limited reuse outside of the purview of the original experiments. Neuroscience data sets are often rich, can be used to answer many different questions, and they are expensive to collect. But often they are practically inaccessible and locked away in the minds of a couple grad students or postdocs who collected the data. Third, using different community scripts, analysis scripts and visualization scripts and software tools requires converting data from one esoteric format to another. And this can be tedious and error prone. And so researchers like you might not even bother trying new tools that can improve your research. How do we solve these problems in neurophysiology? The answer is that we need data standards. Data standards are rules to organize experimental data and metadata so that anyone familiar with the standard or any tool or software tool that is familiar with the standard can understand the data without needing additional information. A few years ago, a coalition of neuroscientists, software developers, and funding groups created the Neurodata Without Borders data standard. And over the past few years, NWB has been refined and expanded to cover the diverse needs of our community. NWB supports the vast majority of neurophysiology data and related metadata, including from extracellular and intracellular electrophysiology experiments, optical physiology experiments, behavior, data acquisition settings, experimental design, and subject information. And now to get to the main topic of this presentation, how does NWB handle other new data types that are not natively supported by NWB, that are not listed in this graphic here? And there are many situations where you might have data that are not natively covered by NWB. Your acquisition system might have metadata that is important for you to understand and analyze the data that doesn't have a particular field in NWB. Your pre-processing or analysis tools might need extra information that is not natively supported. And there are certain types of experimental design parameters that you might want to encode as well. Also, neuroscience is a rapidly evolving field where new technologies create new data types year after year. How do we support these in NWB such that all of your data from new experiments, from old experiments, can all be stored in an NWB file? NWB provides the ability to create extensions to the standard. And this gives NWB the ability to handle these new and specialized types of data. These extensions are packaged with the data, so extended data are always readable and understandable by anyone who has the data files. And NWB conveniently provides a set of tools to facilitate the building, documenting, testing, and publishing of any of your custom extensions for your lab or for your software tool. So briefly, the process of creating an extension starts with identifying a new need. What kinds of data or metadata do you want to store that isn't supported by NWB just yet? And then you can use some of our tools, such as the NDX template, for creating a new neurodata extension. This is an open source template on GitHub that kind of provides the basic framework for what an extension should look like and clear instructions of how to build the extension. Extensions are defined using the same formal specification language as the core standard of NWB. And so you could then use the specification API and the schema of NWB to build your extension and kind of build it off of existing data types as well. Then you can use our basic NWB APIs, the Python API and the MATLAB API, to create custom classes to augment your extension. And then you can document your extension for broader use. Once all of that's done, you have an extension that you can use for storing your data in NWB, which is great. But these data are only, this extension is only known and accessible to you. It would be great to share this with the broader community. The next step you can take is then to distribute your neurodata extension to the broader community by publishing it on popular package managers such as pip and conda, registering it in the Neurodata Extensions catalog. And by doing so, you make it openly available to everyone and well documented. Others can then find your extensions and then read and write data using your extensions in our APIs and publish extension data in any of the neurophysiology data archives, such as Dandy. The Neurodata Extensions Catalog is a new tool that we developed, kind of a web interface where you can browse and explore and search for different extensions for NWB. This is just what it looks like. It's available at nwb-extensions.github.io. And it currently contains a few extensions, such as for miniscope metadata for the outputs of neuronal simulations, for frets or fluorescence resonance energy transfer data, and so on. Now, why would you want to publish your extension to the NDX catalog? We really encourage this in order to kind of build the community and make NWB better and more supportive of all different data types. Well, first, registering your extension makes it easy, makes the extension and its documentation and its source code easy to find. All extensions in the catalog are tested by the NWB team and meet criteria for acceptance, so there's some basic quality control for all extensions in the catalog. And importantly, registering your extension simplifies the access for scientists and tool makers by encouraging one single extension for a particular use case or type of data, rather than 10 different extensions. If you have 10 different extensions for storing the output of your simulations, we're basically back in the world of non-standardized data. Whereas if 10 different groups collaborate on a single extension, then we are on the path toward a single community standard. And as mentioned, having the extensions in the catalog simplifies collaboration and review of extensions for different use cases. And when you publish your extension in the catalog, you, the developer, maintain ownership of your extension, and the catalog just contains a pointer or reference to the source code maintained in your space. And my last point here is that extensions that are published in the catalog and out for public kind of use can then be considered for integration into the core NWB standard. And in this way, the community can drive the developments of the NWB data standard the basic steps are to first create a proposal from an existing NDX in the catalog, and then it goes through 3 different phases of review. One, a technical review by the NWB team. Then we create a working group that will of a specialist in the field to review the extension. And finally, it is openly publicized and reviewed by the public. If the extension passes review, then it will be integrated into the next version of NWB. And in that way, NWB is kind of built and kind of enhanced and curated by the community for the community. That concludes my talk. I'd like to thank the entire NWB team. Showing a few pictures here of the main developers. And we have our executive board who guides the development and path of the NWB data standard. And a number of contributors, including Pam Baker, who gave an earlier talk here. And I'd like to thank our various funding agencies. And thank you for listening.
Thank you, Ryan, for introducing this NWDB thing. And I think it's going to be very helpful for the whole community as well. Yeah, we have 5 minutes for discussions or questions. If you have questions from the audience, please type in Q&A. We now have a question from Andrew. He asks, how can we create positive incentives for sharing data and design in a fair way?
Yeah, so that's a great question. And it's a challenge for the field in general. I don't have a great answer yet.
I really like the pause.
So we can kind of incentivize people to use NWB to publish and share their data by kind of increasing kind of support for secondary analysis of existing data and for the value of having that. Funding agencies can support that as well. They can also create mandates for standardizing your data. In terms of publishing extensions in a shared open way, we hope that by sharing your extension, other people will be able to use it. You're contributing to the community, and you might be able to publish your extension as a small kind of code paper. There are places like the Journal of Open Source Software where you might be able to get that published, and other places where coding projects can get recognized and cited.
Cool, thanks. We still have time for maybe one more topic to discuss. I'm actually curious about the first point you list here. How do I get started using NWB? Is there a website I download something, or there's a workshop or tutorial that can teach me very detailed instructions, like how to do this step by step?
All of those things. So if you go to our website, nwb.org, you can browse and explore our different documentations and tutorials for how to use NWB and how to use the Python and MATLAB APIs for reading and writing NWB data. You can also search Neurodata Without Borders on YouTube and find videos from our past workshops on training users on how to use NWB. And on our website, nwb.org, you can also join our Slack workspace and email a mailing list to learn about updates to NWB and when the next NWB training workshops will be held. There will be another one sometime next year, early next year.
I see. Okay, that will be very helpful to know. Yeah, maybe one more or 2 more minutes to discuss one topic on the second thing. How does NWB support my data type? I'm not an experimentalist, but I have some hard time working with experimental data from different labs and trying to clean up all the data resources into one format that I can deal with. I understand. So that's why I really appreciate such a tool. But like for experimentalists, how does NWB support basically any type of data type people would have, or there's still some limitation there for different data source or different data type?
Yeah, so if your data types fall into extracellular or intracellular electrophysiology, optical physiology, or kind of simple behavior like position tracking, eye tracking, or metadata such as trial information, stimulus parameters, or subject metadata, then NWB natively supports those data types. If you have a particular kind of specialized data type that is just your lab uses, or that was using a microscope that creates new, I don't know, 4-dimensional data that doesn't exist, hasn't been supported just yet by NWB, then you can create an extension kind of using some of the tools that I described earlier.
So it cannot be just directly imported to NWB, but creating their own extension for that. Yeah,
and you can reach out to us to directly to figure out, one, whether an extension has already been created for this, if it happens to be not in the catalog, and two, to get help on creating your extension. It might be we at the NWB team have a lot of experience with NWB for different use cases, and we can provide kind of specialized guidance for your specific type of data and how to get it into an extension. NWB uses composition and inheritance as base principles in the schema, and so you can build off of existing data types, like in case you want to just add a few fields or add a dimension to an existing type.
I see. Yeah, cool. I think thanks for the answer. I think that would be really helpful if people, especially from the experimental side, see the video or attend the talk. We learn, at least they know how to access to this resource and really start to use that. I think that's basically the end of session. And I'd like to thank again for our 3 amazing speakers, Pam, Anqi, and Ryan, to introduce this exciting tools and softwares in the field for people to use and make the experimental design and data sharing way easier. I actually have some experience working with FMI data, where they have their kind of data sharing platform came up like 3 years ago or something, and just I can get access to the data from different labs, download it with all the same infrastructure, very easy to use. But before that, I have to get the data in very different format and clean up them myself. So this kind of thing is also a big contribution to the field, even also for people who only do modeling, but happy to work with different data in the same format as well. So yeah, thank you all for the great talk, and also thanks for the participation of the audience in the attendee list. And yeah, that's basically the end of session. And welcome to continue the discussion on Twitter as well with hashtag NMC3 for any further questions or discussions, and people can also check.